Doing functions pretest. Okay, number one, they are asking if we have an input of -3, what is our output going to be? Take -3, plug it in for x. F of -3 equals 10 minus -3 is our x. So that gives us 10 plus 3, which is 13. Okay. All right, changing colors. Now, same idea. If we have input of x plus 4, that's going to plug in to our x. And we would get the function with input x plus 4 equals 10 minus x plus 4. That negative has to distribute to both the x and the 4. It's like a -1. That would give us 10 minus x minus 4. If we combine our like terms, okay, that's going to give us 6 minus x. Okay, moving on. Number two, it's called a piecewise function. In other words, when x is less than 0, we do that top one. When x is greater than or equal to 0, then we do this bottom function. Okay, so our first one, -2, that is going to go into the top one because -2 is less than 0. Okay, so f of -2 equals 3 times -2, which is -6. Now 0, okay, is going to plug into that one because 0 is greater than or equal to 0, and that means we're going to do the bottom one. So 0 plugs into 3 times 0 minus 5, which equals -5. Number 3, domain and range. Remember, this is the one where I described it as persons. Okay, so people, and then favorite burgers. So if we have people, Joe and Steve, favorite burgers, Burger King, McDonald's, and Carl's Jr. Every person has to eat, and they can only have one favorite. So if Joe's favorite was Burger King, Steve's was McDonald's, that is a function. If Steve also liked Carl's Jr., then that would not be a function. Okay, so every person in the domain has to have a favorite, has to be mapped to something in the range. Okay, so here is everything in the domain mapped to something in the range and only one thing? Yes. Okay, they're all going to 1, but that is fine. So yes, this is a function. Here is everything. Uh-oh. Excuse me. Oiska. Here is everyone in the domain eating? Is everything meaning does everyone in the domain have a favorite or is mapped to something in the range? 5 and 3 are, but not 2. So therefore, not a function because uh, 2 is not mapped to the range. Okay, if we look at C, we have 0, 1, 2, 3. They all are have a favorite. They're all mapped to 1, except 2 is mapped to not only 4, but also to 3. So 2 has 2 is mapped to two things. In other words, as two favorite burgers. We can't have that. Okay, so not a function because 2 is mapped to two y values. Okay. All right. Number 4, we have our two functions, and this is saying add function f and g. So the function f of x plus g of x. Okay, and that means x plus 2 plus 3x minus 4. So do we have like terms? Okay, we can map, or not map, we can add 3x and x, 4x, and we can combine 2 and minus 4. That's negative 2. Okay, that is our addition of the two functions. Now we can subtract the functions as well. X plus 2 minus, and this is important to have the parentheses, minus g of x, which is 3x minus 4. That negative will distribute. Okay, again, combine like terms. And we're going to get negative 2x plus 6. Okay, for C, we are multiplying, so that's going to be f of x. Oh, that's kind of hard to read when it's green. I'll change to blue here. F of x times g of x. And that will be x plus 2 times g of x, 3x minus 4. X times 3x, 3x squared, minus 4x, plus 6x, minus 8. We can combine our x's. Okay, that's going to be 2x minus 8. That is our f times g of x. Now division is going to give us x plus 2, or f of x, divided by 3x minus 4. And to find the domain, we need to see what number makes the bottom 0. We cannot have 0 in a function, okay, in the denominator. Okay, 0 not allowed. So we need to say what would make it equal 0. 3x minus 4 set it equal to 0. Oops. Okay. And so if we solve that at 4, 3x equals 4 divided by 3. So when x equals 4/3, we will get 0 in the denominator. So that is not allowed. Every other term is allowed. So all real numbers except 4/3. Okay, and another way to write that is all reals, big R like that with the double lines, except 4/3. Okay. Now that is that one there. I also want to do next one. Okay. So markup. Markup. We're gonna mark it up. All right. So here they want you to evaluate. Okay. And this is saying we have an input of 2, and the input's going to go to both our f and g functions. So it's going to go in here as well as for g. So that's going to be f of x plus g of x, and our input is 2, so I could replace my x with 2. Okay, so f of 2 is going to be 2 into my x squared minus 1. Okay, that is 2 into x there, plus my g, so 2 is going to go into my x, always in parentheses, plus 3. 2 squared gives me 4 minus 1, plus 2 plus 3. And if we add those together, we're going to get 5 plus 4, that's 9, minus 1 is 8. Okay, so with 2 as my input, plugging in g of x and f of x and adding those, we get 8. Okay, what if we're going to divide with the input of 4? 4 is going to plug in to x and to this x and the g of x. So we're going to get 4 squared minus 1, that's my function f with input of 4, over g of x is x plus 3, so my input is 4. Plugging in here the x, 4 plus 3. Evaluate, we get 16 minus 1 over 4 plus 3. That is 15 sevenths. Okay. Now C is a little bit different. F of g of 5. That means we're going to plug in with g of 5 as my input. Okay. So 5 is going to plug in to there. So that's going to be the function with 5 plus 3, which gives me f of 8. So now I need to take this 8, plug that into f, and see what I get when 8 is the input for f. So that's going to give me 8 squared, because that's what my f function is, minus 1. 64 minus 1, 63. Okay, this next one, that's saying g with f as my input of negative 2. Okay, so negative 2 has to plug in to my f. So that's going to give me g with negative 2 squared minus 1. Okay, I plug that negative 2 into my f function. Gives me g with negative 2 squared. Remember, that's negative 2 times negative 2 minus 1. So g with 4 minus 1, which is 3. So what's my, when I evaluate with 3 as my input for g, that's 3 plus 3. It's going to give me 6. Okay, I know it's getting crazy with all the lines there, but hopefully you're following along. Number 6, find f of g. So that's saying f with g as my input, g of x. I'm going to take this here, plug it in where there's an x. So cube root, and instead of x, we now have x cubed plus 3. And I always sub into parentheses, as should you, minus 2. Okay. Now, since there's no operations going on here, we can eliminate these parentheses. So we just have x cubed plus 3 minus 2. We can combine the 3 and the 2. Gives me x cubed plus 1. And you can't go any further. That's going to be our answer. Okay. For 7, they want us to find g of f, meaning f of x is our input. Okay, so I'm going to take f of x, plug that in as our input into g. So g with the input of x plus 1 equals square root of x plus 1 to the 4th plus 5. Okay, now the square root of x plus 1 to the fourth, remember you can think of, I talked about this before, you can think of as the square root is the same as if it was raised to the 1/2. Okay, that's because this x plus 1 is to the 1 power, and the square root has an invisible 2 there. Now this 4 will multiply to that 1. 4 times 1 over 2. So it'll give you x plus 1 to the 4 over 2 plus 5. 4 over 2 is the same as x plus 1 to the second plus 5. And you could leave it like that, but you could also multiply it out where you have x plus 1 parentheses x plus 1 plus 5. X plus 1 squared, that's going to be x times x squared, x times 1, 1x, 1 times x, 1x, 1 times 1 is 1, running out of room, plus 5. So that gives me, if I combine my like terms, 1x and 1x, we'll get x squared plus 2x plus 1 plus 5, so plus 6. And I'll try that again. X squared plus 2x plus 6. I apologize, running out of room. Okay, I'm going to attempt these last problems. These are the honors problems. So f of g, that means f with g of x as our input. So that 6 is going to go in there. That's going to be the fifth root of x to the 6th to the third power. These powers are going to multiply. Okay, so that's 6 there times 3. So to the 5th power, we get x to the 18th. And that's just, whenever you have power to power like that, that's the rules, is because it's saying we have 3 x to the 6th times each other. It's like this, x to the 6th times x to the 6th times x to the 6th. Okay, so how many x's do we have? 18. Okay, now, to handle this, there's a couple different ways you can think of it. How many groups of 5 do we have? If there's 18, that means we have x to the 5th times x to the 5th times x to the 5th. That would add to 15. And then there's 3 left over. Okay, so that is my x to the 5th. If I have groups of 5, that means I can pull out one of those terms. So for the first x to the 5th circle, I can pull out an x. Second x to the 5th circle, I can pull out an x. Third one, pull out an x. And then there's 3 left over. So that would be x to the 3rd, 5th root of x to the 3rd. Okay, and it's like, if you think about it, okay, let's say I had the square root of 8. Square root has an invisible 2 there. We're looking for pairs. So if we had the square root of 8, that's 2 times 2 times 2. We have a pair of 2's. That means a 1, 2 can come out of the square root, and then there's one lonely 2 left in. Okay, so that is how square roots work. Let's see if we have enough room for my last one. F of g, that's going to be, my input is going to be g of x. That is going to plug in to x. So cube root x to the 6 minus 5, that's being plugged in for x, plus 5. Nothing is happening with the parentheses. Okay, so I can actually get rid of them. And I can combine minus 5 plus 5. Those cancel out. So I'm looking at the cube root of x to the 6th. So cube roots, we're going to need a pair or not a pair, we need three of a kind. So do I have three of a kind? Yes, I can break that 6 up into 2x squared, x squared, x squared, meaning I have 3x squareds. So an x squared would come out of the function. Okay, and let's hope that recorded.